This is part 2 of InteGrid 1 mini lecture for 9.2.1 and 9.2.2. Okay, 9.2.1 and 9.2.2. Okay, so we were on number 11, and so there it still is, and we graphed it, and then it has an inequality, so we're going to shade it. So this is less than. So if y is less than, then that less than means under, so I'm going to shade under the graph. So anything under the graph, because the big y numbers, that's y. The big y numbers are up there, but I'm shading less than, so that's under. Okay, and just shade it. I guess that's sufficient. Let's do that was number 11, just finished it. The first part of number 11 is on the previous part 1, in case you're wondering. Number 12. So I only wanted to do number 12 because I wanted to compare it to number 11. So number 12 is y is greater than 2 to the x minus 3. Now, I don't think you've seen any of these. Well, you probably know it's an exponential, like y equals a times b to the x. But these can get shifted up and down and get moved around a little bit, and that's called a translation, which we haven't talked much about those. But let's just see what happens when we do this. So we're going to kind of do the same thing. Starting point is probably 1, but then it got shifted down by 3. So just to make sure, we know the multiplier is 2. Just to make sure, let's just plot some points. It doesn't take very long to plot the points. So I like to use 0. 2 to the 0, everybody knows 2 to the 0 is 1, right? 1 minus 3, well, what does that give? 1 minus, that's negative 2. Okay, so I'm going to get negative 2 there. And that's what I thought it would be. I thought it would be shifted down. It was up at 1 and it got shifted down by 3. So there's the starting point right there. Okay, it's probably going to have the same shape as this other graph, but my prediction is that it's going to look exactly like this other graph, but just shifted down by 3. We'll check it though. Let's plug 1 in. Well, we know we can actually get these numbers just by multiplying by 2, just like we did up here. The multiplier was 2, right? So some of you know that you can just keep multiplying by 2. Right. So I can do it that way, or I can plug the number in. If I plug the number in, I get 2 to the 1 is 2, and 2 minus 3 is negative 1. And, hey, wait, 2 to the 1 is 2, and 2 minus 3, that's negative 1. So let's see what's going on with this thing. Let's try plugging in 2. 2 squared is 4, and 4 minus 3, that's 1. Let's do 3. Okay, 2 to the 3rd. Oh, I'm seeing a whole bunch of different things going on here. I hope you guys are noticing some things. I know this is just supposed to be showing you how to do it, but if you read in your book, they'll probably have some explorations on this stuff. 2 to the 3rd is 8, and 8 minus 3, well, I think that's going to be 5. Isn't it? Now, when I look at these numbers and I look at these numbers, I think these numbers are the same as these numbers except for just subtracting 3, right? Because 1 minus 3 is negative 2. 2 minus 3 is negative 1. 8 minus 3, So it kind of messes up my thing about the multiplier, though, because when I try multiplying that by 2, that doesn't quite work out. That times 2. But it does show that it's all these points just shifted down by 3, because if you look, and then the negative, if I put -1, that'd be a half. I don't really want to do that fraction math. Well, I could do it though. I guess I better. 2 to the -1 is a half, and a half minus 3 would be, I don't know, that's 1/2 minus 6/2, that'd be -5/2, which is -2.5 or something like that. Okay, so let's put some of these on our graph. So I like the 1, -1. That looks like a nice one to do. Okay, so 1, -1's right there. 2, 1. Can you see all this? 2, 1. So 3, 5. 1, 2, 3. 1, 2. My scaling's off. 1, 2, 3, 4, 5. Let's just say it's not drawn to scale, okay? Do you want to do another one? Let's do one more. 4. Well, 2 to the 4th, that'd be 2 times 2 times 2. That's 16 minus 3. 16, that's 13. 4, 13. So that's going to go off my graph. It'd be way, way, way up here. So I think I can just kind of fake it. Now at -1, -2.5 would be like kind of here, right? So it's gonna kind of still, you know, go down off this way. We're not going to get too detailed about it, okay? But so can you see like how the graphs kind of look the same? It looks like we grabbed this one and we just like kind of dragged it down by a few notches, right? By 3. So probably made too big of a deal about that. This says greater than. Oh, and look, it doesn't have the little equals thingy. So now I have to make sure that this looks like a dotted or a dashed line. Okay, so whenever I mess up and I make it a solid line and I want it to be a dashed line, I just make dashes on it so it still looks like a dash. Does that look like a dashed line? It's supposed to. Okay, and then I'm going to shade above it because it says greater than. Probably spent too much time talking about that one. Okay, so basically you're just plot some points, you know, make some, if you want to make some observations about these, that's great. We'll talk about these when you come back from your testing. That was number 12. Okay, the other one I wanted to do was number 14. And 15, I don't know, maybe I'll have to make 3 videos. Number 14. Y, maybe I'll just do number 14. Y is less than 4 and then 1/2 to the x. So this is in y equals ax plus b form that you guys remember you used to do this, y, or ab to the x. So that helps me a little bit in my graphing because, you know, at least I can go, oh, well, the starting point is 4. And, well, I still feel like I should plot some points, though. Just plot some points. Okay, so let's pick -1, 0, 1. Maybe go from there. We'll see how that looks. So -1. So 1/2, I hope you guys know this, 1/2 to the -1 is 2. Okay, if you don't know that, check it out. Maybe go in and go on a video about negative exponents so you can figure it out. -1, 2. Oh wait, well that's going to be 2. 2 times 4, that's 8. -1, 8. I'm going to go ahead and close this video out and start part 2, and then we'll finish this one.